The question says that find the maximum frequency and minimum wavelength of X-rays produced by 30 kilovolt electrons. Now here we have been given the energy of electrons in the terms of voltage. So we can find out the energy of photons of X-rays produced with this formula E max equals to E times the voltage. So we know that when high energy electrons strike a target material in an X-ray tube, they produce X-rays. Now the minimum wavelength of the emitted X-rays corresponds to the maximum energy of the X-rays photons, which is given by this expression E max equals to E times V. Now how this minimum wavelength corresponds to the maximum energy, we can see that H E equals to H times nu given by Planck's equation. Now here nu is the frequency and this frequency is given by C upon lambda. Now when this wavelength would be lowest, then this expression for frequency is going to be highest, thus E gets highest. Now we have been given the value of V over here, that is 30 kilovolt. So we can use this expression to find out maximum value of energy of photons. So we have seen that how Planck's equation is helpful in calculating the energy, and we can see how the frequency and wavelength are related with the speed of electromagnetic radiation, that is C equals to F times lambda. So computing maximum energy of X-ray photons. Here E max can be calculated as E times V. Now E, we know that the charge of electron is 1.602 into 10 to the power minus 19 coulomb, and V has been given, that is 30 kilovolts. So E max would be given by E times V, or 4.806 into 10 to the power minus 15 joule. Now corresponding to this energy, what would be the frequency? Now we can calculate the frequency using Planck's equation, that is E equals to H times lambda, H times C by lambda, or H times nu. We have to calculate this frequency. So frequency would be equal to E by H, E max by H, where H is the Planck's constant, and we know the value of Planck's constant as 6.626 into 10 to the power minus 34 joule second. So substituting the values, we will get a value of 7.25 into 10 to the power 18 hertz. Now computing minimum wavelength for this corresponding frequency, we can use this expression of speed of light or speed of electromagnetic radiation, that is C equals to lambda times frequency. We have been given the frequency, or we have calculated the frequency from above expression. So we will substitute this, the value of frequency, and we know the value of speed of electromagnetic radiation, that is 3 into 10 to the power 8 meter per second. So we can calculate lambda minimum over here. So calculating this, we will get a value of 0.014 nanometer. Thank you.